So we're going to do an example for standard union vectors here. So I have P and Q set up as points, and I'm going to let U, the vector U, represent the directed line segment from P to Q. And I also have a vector V, which is already defined in terms of standard unit vectors. So we want to go ahead and find U in terms of I and J, the standard unit vectors. And then we're going to use that with V in part 2. So let's get started. So to get I and J, I really need to get those individual components. So if the directed line segment from P goes from P, it's the initial point, and terminates at Q, then the X component, or the ith component, right, that standard unit vector, is going to be -1 minus 2i. And then when we get that jth component, or that second or y standard, or the standard vector for the y dimension, 3 minus -5. So that's going to get us that u is -3i plus 8j. And a simple way to verify that we've done this correctly is just to add these components to see if we get to Q, right? If I start at P and I add -3, I get -1. If I add 8, I get +3. So we can be reasonably confident that we did this correctly. So that's our first piece. Second piece, we want to find 2u minus 3v. So let's be a little more clever with this. Let's get 2u. So 2u is simply 2 times each component of u. So that gets us -6i plus 16j. And instead of getting 3v, let's go ahead and get -3v. So -3v would be -3 times each of these components. So that's going to get us -6i plus 3j. So now, instead of doing 2u minus 3v, we can do 2u plus -3v, right? We can say 2u plus -3v. Oh, and look, I've got it to where we can add it. It's almost like I did that on purpose. I actually didn't. I got lucky. But anyway, using that sort of structure allows you to easily combine these. So that's an example.